Okay, so today we're going to start section 4.4, which is on trig functions of any angle. So no longer do we have to be in the unit circle. So they give you these definitions, and honestly it just boils down to SOHCAHTOA again. So honestly don't know why they try to make it more difficult than it needs to be. So there are definitions. If you're inside any circle, not just the unit circle, then your definition of sine is going to be y over r, which is still, if you are looking at this, if you were to make a triangle here, and this is your angle, that's still opposite over a hypotenuse, because your r is that radius of your circle or the hypotenuse. So again, it's still just SOHCAHTOA, so you don't have to memorize anything new. Alright, so we're going to find the value of the 6 trig functions for an angle in standard position if a point with the given coordinates lies on its terminal side. Okay, so what that means for you is you're going to draw yourself a picture. So we're saying that if we're in the xy coordinate plane, go to the point -3, 4, draw an angle that goes through there. So technically this is your angle, but we can think of it as really this is the angle, and draw a triangle. So if this is 3 and this is 4, then we know that the hypotenuse is 5 because of a 3, 4, 5 right triangle. It's a Pythagorean triple. Or if you did 3 squared plus 4 squared, you would get 9 plus 16 is 25. The square root of that is 5. Alright, so to get your 6 trig functions, you're just going to think SOHCAHTOA. It's nothing that we haven't done before. So from this angle, you would have opposite over hypotenuse is 4/5, adjacent over hypotenuse is -3/5, opposite over adjacent is 4 over -3 or -4/3. And then cosecant, secant, and cotangent are just the reciprocals of those. So the reciprocal of sine gives us 5/4 for cosecant. The reciprocal of cosine gives us -5/3 for secant. The reciprocal of tangent would give us -3/4 for cotangent. Alright, so using those definitions up there, you still have to figure out what the radius of the circle is. So you still have to figure out the hypotenuse. So you're still going to have to know that this is 5. And then the definition for sine was y over the radius that you just found, 5. So either way you think about it, you're going to get the same answer. So I say why think about it as something different. Just make a triangle, use SOHCAHTOA. Alright, next example. They give us the point 8, 15. Alright, so find the point 8, 15. Draw your terminal side. So this is my angle. So if this is 8 and this is 15, the Pythagorean theorem tells me that this is 17. Also, 8, 15, 17 is a Pythagorean triple. I don't really expect you to memorize those, but they are posted on my classroom wall. So you would be able to look up there and see if you are in class. But again, it's the Pythagorean theorem, so remember you're just going to do 8 squared plus 15 squared equals that hypotenuse squared. So 64 plus 225 is equal to the hypotenuse squared. So what is that? 289 is equal to the hypotenuse squared. So if you take the square root of both sides, that means h is 17. Alright, so now that you know where that 17 came from, we are again just doing SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then you just do the reciprocals to get the other 3. So cosecant, you take the reciprocal of sine. Secant, you take the reciprocal of cosine. Remember, reciprocal just means flip the fraction over. Cotangent is you take the reciprocal of tangent. Alright, number 3, I want you to pause and try it on your own and then play the video and see how you did. Obviously, don't look at the screen because you can see those. So pause it while my hand's there. Now try it and see what you come up with. Alright, so this picture was there so you could see what that hypotenuse was supposed to be, but just walking you through this. We drew our picture, we went 7, -4, made our angle. Technically it's this angle, but we can use this as the angle for our triangle to get our different values. All right, so if we have 7 squared plus negative 4 squared, that's 49 plus 16, which is 65. Take the square root of that, and you just have the square root of 65. Sometimes those radicals will simplify, but 65 doesn't have a perfect square factor. Like it's not divisible by 4 or 9 or 16 or 25 or any of those perfect squares. All right, so we can call this hypotenuse side the square root of 65. All right, so sine is going to be opposite over hypotenuse, so negative 4 over the square root of 65. And remember that we have to rationalize, but all that means is the radical moves to the top and you lose the square root symbol on the bottom. So negative 4 root 65 over 65. For cosine, it's going to be the adjacent over hypotenuse, so 7 over the square root of 65. And again, we rationalize, so move the radical to the top, lose the square root on the bottom. Tangent is just the opposite over the adjacent, so negative 4 over 7. And then for the other three, it's just the reciprocals. And remember that we discussed earlier in a different lesson that we can take the one where the radical was on the bottom and flip it so that we don't have to rationalize when we do the reciprocal. If you tried to do the reciprocal of this, you'd rationalize, it'd be a lot of work. But if you back up and take this one and flip it, then there's no extra work to be done. So again, back up and take this one and flip it. And then here you just do the reciprocal of negative 4/7. All right, so number 4. Technically, we don't have a triangle going on here. So this is a situation where you kind of need to know the whole y over r, x over r. Okay, so this is our ordered pair. We can't draw a triangle with a side length of 0. So we have to remember that x is 0, y is 5 from the ordered pair they gave us, and we know the radius of the circle is 5, because if I have a circle that's going through this point, then it has a radius of 5 units. All right, so sine is going to be y over r, so 5 over 5, which is 1. Cosine is x over r, so 0 over 5, which is 0. Tangent is going to be y over x, so 5 over 0. Can't divide by 0, so that's undefined. The reciprocal of 1 is 1. The reciprocal of 0, put 0 in the denominator, so that's undefined. But this undefined, when I flip this guy, I put 0 in the numerator, which is okay, so the answer is just 0. Okay, so next. The signs of the trig functions in the 4 quadrants can be determined from the definition of the function. Okay, so the sign, as in is it positive or negative, can be determined by the definition of the function. So remember that sine is y over r. Well, radius, if we're in the unit circle, is always 1. If we're in any other circle, it's always positive. So it boils down to, do you know the signs of y, and do you know the sign of x? All right, so sine is the y. So the y-coordinate of an ordered pair is going to be positive when you're above the x-axis. So sine is positive in quadrant 1 and quadrant 2, because those are the ones that are up from the x-axis. Sine is negative in quadrant 3 and quadrant 4, because you're going down from the x-axis. All right, so cosine is the x. All right, so if we are in the positive direction on the x-axis, so that would be quadrant 1 or quadrant 4, cosine is going to be positive. If we're in the negative direction on the x-axis, so quadrant 3 and quadrant 2, cosine will be negative. All right, tangent involves y and x. So if x and y have the same sign, tangent is positive. So in quadrant 1 and in quadrant 3, tangent's going to be positive because x and y have the same sign. In quadrant 2 and quadrant 4, tangent's going to be negative because x and y have different signs. All right, so when you take the unit circle test, you're going to have to label the quadrants. You're going to have to tell me what the ordered pairs look like in each one, and you're going to have to tell me which things are positive and which are negative in each quadrant. So a way to remember that is the ones that are positive. You can remember why all students take calculus. All of them are positive in quadrant 1. Only sine, the one that starts with S, is positive in quadrant 2. Only tangent, the one that starts with T, is positive in quadrant 3, and only cosine, the one that starts with C, is positive in quadrant 4. Okay, so number 5 says state the quadrant in which theta lies, and they're just going to give you some information about theta. Excuse me, sorry. I was reading something. All right, so if sine is less than 0, meaning sine is negative, that means the y-coordinate is negative. Cosine is less than 0, which means negative, so x is negative. So if your ordered pair has a negative x and a negative y, you're in quadrant 3. All right, the next one, if secant is greater than 0. Okay, so if secant is positive, it means cosine was positive, because cosine and secant are reciprocals, so that means your x is positive. For cotangent to be less than 0, that means that it has to be negative. Well, if cotangent's negative, then so is tangent. And for that to happen, x and y have to have different signs. And since we said x is positive, that means y has to be negative. So we're looking for a positive x and a negative y. That's in quadrant 4. All right, so that's it for today. In class, we are doing a practice unit circle, so take the time to do that. And we may also do a little bit of whiteboards if we have time. I'm going to say, tell me the sine at 45 degrees, and you have to be able to tell me what sine a 45 degree is. So remember that all you have to do for that is think about where 45 degrees is on the unit circle. Sine is the y-coordinate, so it'd be root 2 over 2 is the answer. All right, so at this point, we should be getting really close to being able to picture where angles are on the unit circle and telling me what I'm looking for, whether I ask for sine, cosine, tangent, whatever. All right, again, if you have questions, please let me know.